Thank you very much, everyone, for coming to the last presentation of the day. I am Liliana Velázquez Montoya. I'm a postdoc at NC State in the Department of Civil Construction and Environmental Engineering. And today I'm going to show you the results of habitat classification and some change analysis from color infrared imagery in a barrier island here in North Carolina. So my presentation is structured as shown in this slide. First, I'm going to give you a little bit of background information and context for the motivation of this work. I will explain you what my study area is and the objectives of this work. Then I will tell you a little bit about my data and the methods that we're using for the classification. And following, I will talk about the results on the habitat change and analysis for a 6-year period. And then I will finish with the summary of our results and the next steps for this study, because this is an ongoing project. So my study area is located in the Outer Banks of North Carolina. It is the Pea Island National Wildlife Refuge, which is a 21-kilometer long stretch of the Outer Banks. In this section, the island has widths that range from about 200 to 1,700 meters. And there is a dune ridge that has maximum elevations that range between 3 and 10 meters all along the refuge. As you can see in this image, the refuge goes all the way in the north from the south end of Oregon Inlet to Rodante in the south. And the infrastructure in this area is relatively sparse. The main piece of infrastructure is the NC-12 highway, which is this yellow line that hopefully you can see over there. This road is the only terrestrial route for the town south of the refuge to connect with mainland North Carolina and for the refuge itself. Other than the road, there is a terminal groin that is located in the top or in the tip of the island. This terminal groin was built in 1989 to prevent Oregon Inlet from migrating southwards and possibly endangering the southern abutment of the Bonner Bridge that crosses the inlet. There is also a wildlife refuge visitor center and a little parking lot, and some other small facilities for the operation of the refuge. And last but not least, there are 3 man-made impoundments that you can see here too, and their locations in red. These impoundments were built to enhance habitat for migratory waterfowl. And as you can see, and as we all know, infrastructure is somewhat static, but we know that this island is actually very dynamic, and that a lot of changes are occurring in this island. So I'm going to point out just some of those changes so that you get a little idea of what we're seeing from real color images. This is in the middle of the refuge where Hurricane Irene in 2011 opened an inlet. You will see that appearing actually right now. Then this inlet closed naturally. So we know that there are a lot of changes happening in this area. Also, other smaller changes are due to overwash deposits after storms, and also due to shoreline change positions in this area. Another example, more towards the north part of the refuge, is shown in this image. You can see the development of massive overwash deposits after Hurricane Sandy in 2012, and later on those overwash fans get vegetated. And in addition to these 3 dots that were showing those overwash fans, I'm also pointing out this region right here where there is a channel that is becoming larger or wider and wider over time. So we know that these changes in landscape are happening, and one way or another, those changes in landscape will translate in changes in habitat as well. So we need to identify, quantify, and analyze those changes so that the agencies that are managing the land and the infrastructure in this region are able to make informed decisions. So with that in mind, our objective is to assess the changes in those habitats from color infrared images from 2012 to 2018 at the Pea Island National Wildlife Refuge to inform NCDOT and the Fish and Wildlife Service, which are the agencies that are managing the infrastructure and the land at this barrier island. So the data that we're getting comes from the long-term coastal monitoring program. This is a program that was designed by NCDOT to assess the vulnerability of NC12 highway along the refuge and to assist in deciding when planning efforts for future phases of NC12 should begin. As part of this project, we are getting annual color infrared images with a resolution of 1/2 foot. And in addition to that, we're also getting photogrammetrically derived digital terrain models for every April. So we have one photo covering all the island for every year since 2012 until 2018. And this is only one portion of that coastal monitoring program. Actually, they are taking many more data. So with all this data in hand, we had multiple meetings with personnel from Fish and Wildlife Service to identify what were the classes that would make sense for them to have for their management purposes. So we end up deciding in 13 classes, and some of them are more obvious than others, you will see. So bare sand is an obvious one, just patches of sand with no vegetation. We are also classifying estuarine ponds, which are enclosed bodies of water within the island. Salt flats, which are regions that are exposed to irregular flooding from salt water. Shrubs, this is obvious. Marsh, we initially were very optimistic and were trying to map developing marsh and trying to differentiate it from well-developed marsh, but at the end, this was causing a lot of headaches, so we just stick with marsh. We are also classifying dunes. The way we're doing this, I'm showing you here a profile, so this is an elevation profile that we are extracting from those digital terrain models that we are getting. And these profiles are extracted at transects separated every 150 feet. And the way the dune is mapped is that the back of the dune, that will be this line that you're seeing here in black, will be the 5-foot contour, and the front of the dune will be the dune toe that we are extracting from an algorithm that we have that traces a line between the dune crest and the shoreline, and it gives us the maximum distance or the maximum vertical distance from that line to the profile, and that will be the dune toe. So for us, the dune will be this red arrow right here, or the area between these two lines, like if we were looking from the top. We are classifying water, both from the ocean side and the sound side. The groin, which is an infrastructure, a part of the infrastructure, but there is of particular interest to have it separately than the rest of the infrastructure that will be the visitor center, parking lot, the road itself. And we are also extracting maritime brush, which refers to those regions where there is vegetation growing after overwash fans developed. So these are regions that are usually behind the dunes that are prone to flooding and also to sand deposition due to wind processes. We are also mapping the managed wetlands, which actually refer to those man-made impoundments that I mentioned before. I'm showing just one for the sake of space. And the beach, which goes from the dune toe line, which will be this line if we were going back to the dune, and the wet-dry shoreline. We are digitizing this shoreline specifically for the date of the photo. And there was something that I just forgot to say, and is that for the dune, we're actually separated the dune in two categories. We are having a vegetated portion of the dune and a bare sand dune. So having decided on these 13 classes, the process that we are actually following to do the classification begins by resampling the image. So as I say, we have a 1/2 foot resolution. And while doing the classification, we were having obviously a lot of noise initially from these high, like extremely high resolution photos. Here you can see that we can even see the details on the cars. Those are things that for these purposes are not necessary. So we actually resample the images to a 2 feet resolution. And from there, we remove the ocean and the sound by masking the island. And what the areas that we mask out end up being the water from both the ocean and the sound. And then we do the actual classification, which we're doing via two methods. We are doing supervised classification with training polygons in ArcGIS for the bare sand, storing ponds, salt flats, shrub, marsh, and water categories. And then we are doing partial digitation and partially, I would say, semi-automated for these other categories: growing, infrastructure, managed wetlands, maritime brush, dune, and beach. In our case, because the growing, for example, tends to be relatively static, we just digitize it once and just keep checking that there are no major changes. So that actually accelerates the process of digitizing everything. And then, of course, we have to go through a detailed cleaning and fixing of the raster that we're getting, because still there are a lot of challenges for the supervised classification. Some of the challenges including, for example, when we try to differentiate bare sand with salt flats, because the returns that we're getting are very similar. So there are still some issues there. And also shadows are an issue because they are they are represented as darker colors, and water is also represented as darker colors. So we have to go through all the image and fix those mistakes. So at the end, we have a product that looks sort of like this. This is just a zoom in a particular area of the refuge. On the left, you see the color infrared image, and on the right, how the map will look like. In general, while capturing the main features, here you see, for example, the salt flats that I was talking about. This one is one of the man-made impoundments, which will be the managed wetlands, the marshes, some of the shrubs. So this is how our results generally look like. Now, talking about the changes per se, I'm going to first talk about general changes. So earliest date versus latest date, and then we will see what is happening in between. So the earliest date that we have is April 2012, the latest April 2018. This is how those maps look like. And in order for the managers, people from DOT and Fish and Wildlife, to actually see what is going on, we are generating some change maps. Here you see in black the areas that have gone through any change, and in gray the areas that have remained in the same class. One thing to point out is this region here in the center. That's the same region that I showed at the beginning of the presentation where that breach occurred in 2011. So we're actually seeing that our results are at least matching those big things. And because these results don't give us a lot of detail of what is exactly happening between classes, we are creating change matrices that look like this. What these matrices are showing are actual areas. So the numbers are areas in acres, and the colors indicate green, which is the middle of the matrix or the diagonal of the matrix, those areas that have remained in the same class. Lighter colors, smaller areas, and warmer colors, larger areas. The way to read this matrix is by looking at, on the left, we have the earlier year, so 2012, and all the classes, and on the top we have the latest year, 2018, and all the classes. So as an example, if we wanted to see what was shrub in 2012, what areas became marsh in 2018, this will be the number to look at, and that is 364 acres, more or less. And this is especially how that look like, those areas that have gone from one category to another. And in this particular location, here is an example. Let me see if the video will play. You are looking at the 2018 first, and 12, and now the 18 darker. So we are able also to compare that, or like to double check that these changes are actually happening. Another example will be what was bare sand dune that is now vegetated dune. Those changes are happening mostly on the south part of the refuge, where we actually know there is a very well-developed dune ridge with vegetation. Again, this will be the example for that region. If it plays, let me see. So we have the two images there for those specific dates. So we have the matrices for every single year. I'm not going to bore you with all the changes for all the years, but I do want to show the trends that we're seeing from all those years. So in these plots, you see a lot of things. Just focus first on the ones that I'm highlighted in red here. So in the x-axis is year, and in the y-axis we have areas. So I highlighted those classes that are actually showing some sort of trend going on. So for the bare sand, we see that there is a decrease in bare sand overall from 2012 to 2013. For vegetated dune, we see an increase, bare sand dune decrease, infrastructure somewhat increasing, but actually that will get stabilized hopefully this year, because they were doing a lot of construction of the new bridge in Oregon Inlet, but after that is finished, these values should sort of become horizontal. And then for managed wetlands, we are also seeing a slight decrease. For the other categories, it's hard to point out a specific trend. Their behavior is more erratic, and that could be just because for that specific date, the water levels were higher, or like specific events that happened just before the photo was taken. We were also able to identify the area of the island. So this is telling us that overall, between 2000 or in these 6 years, the island has changed between 100 acres. But there is also not a trend. It's not like the island is becoming slower or larger. This is also a behavior that comes like back and forth. And with this data, we can also identify what percentages for each class are part of the island. So for 2012, the dominant class was marsh, followed by managed wetlands and shrubs. For 2013, you can see the same plot. Marshes is still being the dominating class, but higher, up to 45%. We see an important decrease in shrub, and this trend sort of maintains itself until 2016, when we see an increase in shrub again. And the latest data for 2018 is showing us an overall dominance or predominance of marshes in this region, followed again by managed wetlands and shrubs. The rest of the classes are usually below 10% of the total area of the island. So with that, for now, we were able to define these 13 classes in discussions with personnel from DOT and Fish and Wildlife. And we are right now assessing their changes from these high-resolution annual color infrared images that NCDOT is providing. The results from this study will hopefully inform NCDOT and Fish and Wildlife about these changes, and will allow them to make informed decisions for the sustainable management of the land and infrastructure that they are responsible for. And the next steps for this research are that we are actually mapping additional images for 2009 and 2010. Those images don't have the whole extent of the island, but we are still hopeful that we can find some additional information that will help us make our data set larger. And after that, the idea will be to start trying to make predictions of habitat changes via environmental modeling tools. So thank you very much. I'm right on time. So actually, that contour a lot of times actually matches the road, and because the road goes all along the island, there is that's where the dune is kind of cut, and it also in areas where the dunes were vegetated, it will also mark like certain features that were very specific of the dune. Initially, in the first phases, we were trying to do a more subjective classification, but then we were like, there is not an actual criteria, while the 5-feet contour will be a more standardized value to follow. So actually, as I said, this data comes from the Coastal Monitoring Program, and this is a project that has been in place since 2011. But before that, there has been a terminal growing monitoring program. So NCDOT is required by Fish and Wildlife to monitor shoreline changes in this region to ensure that because they built that terminal growing to protect the bridge, they need to ensure that that terminal growing is not accelerating the erosion in the refuge. So they have been actually taking bi-monthly photography of the island since 1989. And some of my co-authors have been working with them since 1989. So I'm actually the newer one in this project.
Have you considered, I think NC State may have an option to access the Planet Labs daily data, try to use that data in addition to the 1 meter data to try to get a better handle on the change in vegetation over time?
No, I have not, but that's a good idea. So this will be just daily data of this?
It's 3.5 meter resolution.
Okay.
4 band.
Okay. Okay, we could compare. I mean, this is still half a foot. So we are talking about 15 centimeters compared to 3 meters. But yeah, I mean, we could just double check. Mm-hmm.
Wondering about, it looked like some of those changes in marsh were pretty large year to year. I'm just wondering if, I guess it's percentage.
Yes. Yes, so actually, if we go back, I guess you are referring to these plots. So because it's percentage, that may give the wrong impression, but the actual, if you wanted to see the actual change, will be this one. Because this is for the total area of the raster. So we are talking about that's the total area, not percentage. So we are seeing some changes there, but nothing that I would call critical. Yes, so actually these photos NCDOT tries to take these photos at high water, but of course sometimes for weather conditions or for any other reasons they cannot fly at high water, but they try to do it as close as possible. So some of the changes in the island area are actually due to changes in the shoreline position. And we are aware of that. And that obviously has a certain effect. So that's why we are looking at total areas versus also percentages, so that we are aware that both things should be considered, not only percentage of the island. Actually, these will be the more relevant values. Okay, no more questions? Okay. Enjoy the poster session, I guess?
Yeah, poster session. Probably beer.